we go, losing self-control.
Hello again, this is Motionology. Welcome back. RayCollision is the new operator that we will talk about right now, and this RayCollision is very cool and very useful. So you're gonna have to pay a lot of attention for this one. RayCollision has three inputs: object and ray point 1 and ray point 2. This RayCollision will create an invisible ray between the point number 1 and the ray point number 2, and if this invisible ray intersect with the object, then we do have a true value. If there is no intersection whatsoever between the object and the ray generated between these 2 points, we do have a false value. In my scene, I do have a couple of objects. Do have object A and object B, and I do have this moving plane in between. So let's see what RayCollision operator does in action. Let's bring all of these objects into Xpresso. I do have the object, which is the plane, and we do have the object A and B, which is these spheres right here. So let me connect that plane to the object, import port in the RayCollision operator, and let me extract the position for the spheres A and B. All right, and then let's connect them to ray point 1 and ray point 2. Now this sphere A will send a ray to the sphere B, and this ray will intersect with the plane. So let me grab a result node, and let's change the data type from real to pool, and then we do have a false value. Let's connect that to the collision. Now we do have a true value because there is an intersection between the invisible ray and this plane. Now if we just move these away from the plane, now we do have a false value. If we just get them back, we do have a true value. False value, true value. For this RayCollision, we do have some other outputs. Distance, face index, face normal, hit position is back face, Fong Normals. We will talk about these things, and now let's begin with this hit position because it's very interesting. And this hit position will give us the coordinates of the point of intersection. So let me grab another object, let's say a cube, and let's make this cube very small. Let's say 20 by 20 by 20, and then let me grab it into Xpresso, extract the position. Let's connect that to the hit position because it's a vector value. Let's connect that. Now this position, let me just change its color, make it red, and now nothing really happens because in this RayCollision we have this test only option checked on, and for these things to work in the RayCollision we need to uncheck this test only, and when we do that the cube will jump to the intersection point between the ray and this plane. Now if we just move these two objects, the cube will move along. Now if we just hit play just for this plane to move, you can see that this cube is moving along with this noise displacer that I added to this plane, and this is very cool. This distance will output a real value, and it will calculate the distance between object A and the plane. So let me grab a result node, another one, and then just keep it real. and let's connect that. Now we do have this number, which is the exact distance between the intersection point and the object A. If we just hit play, we're gonna see this value changes over time because our plane is moving. And because we do have this animation refresh checked on, we do have this number changing over time. All right, another thing that we will talk about is this face index, which will give us the face index number that this ray is actually hitting. Okay, and now let me grab another result node. Real, it's okay. Let's connect that. Now the exact face on this plane that is intersecting with this ray is the face number 1176. Now if we just select this plane and go to the structure and just change the mode from point to polygon, we can have these index numbers of each polygon on this plane. And we do have 2,499 faces on this plane. So this face index is giving us the exact index number of this face that this ray is intersecting with. Now if we just move these two objects, we're gonna have different number in here because this ray is hitting a different face now. Okay, another thing is the face normal, and this is a normal data type, and will give us the normal value of the face that this ray is hitting. And let me change this from real to normal, and then let's connect that. Okay, we do have this value of the normal, and we do have another thing that we will talk about is back face, and this is interesting. It's a pool value, and it will be true if the ray is hitting the back face of this polygon that this ray is hitting. So let me grab another result node and let's change the data type to pool. So now we do have a false. Let's connect that. We do have false because it's hitting the front face of this polygon. But if we just select the plane and just rotate it 180 degrees, we do have a true value because this ray that has been sending from the object A to object B is hitting the back face of that polygon. All right, let's just get it back to the way it was, and we do have false value again because now it's hitting the front face of that polygon. The last thing in this RayCollision operator is the Fong Normal, and this is somehow similar to the face normal. It's just going to deal with the normal, but this Fong Normal is going to deal a bit too much about the surrounding polygons that this ray is colliding with. And if we just grab a result node, we're going to have a value based on that. Now let's connect it. All right, and we do have a value in here that deals with the Fong normal of that specific polygon that this ray is colliding with. So this is it about the RayCollision. I hope it makes sense, and maybe later on after we finish with these nodes, we will make more practical examples on how to use all of these things. Thank you so much for watching. I'll see you next.